Relative atomic mass. The relative atomic mass of an element is an average value that takes account of the abundance or amount of the isotopes of the element. For most elements, if we look on the periodic table and we find our standard symbol, then the relative atomic mass is simply the top number. You'll notice on the periodic table that some of the elements don't have a whole number for the relative atomic mass. Chlorine in particular is one that people tend to quote when they look at this. The reason that chlorine doesn't have a relative atomic mass that is a whole number is because chlorine has two isotopes. It has an isotope of chlorine with a mass of 37 and an isotope of chlorine with a mass of 35. The isotope with the mass of 35 accounts for 75% of all of the chlorine on Earth. The isotope with a mass of 37 accounts for 25% of all of the chlorine on Earth. If we took a sample of 100 atoms and we worked out the average mass, that would give us the relative atomic mass. So the formula that you would use would be relative atomic mass equals the percentage abundance. Don't be put off by the word abundance. Abundance is just a posh word for amount. Multiplied by the mass of that particular isotope added to the percentage abundance times the mass of the isotope, all divided by 100 because we're going to consider 100 atoms. So for chlorine, if 75% of our 100 atoms are chlorine 35, then our abundance is going to be 75, multiplied by the mass, which is 35, added to our abundance of the other isotope, multiplied by 37, which is the mass of the isotope, all divided by 100. Now at this point it's really important that you can use your calculator. It's very easy to get a number that you think is the correct answer and is actually totally wrong. The answer for this question is 35.5, which is what we would expect because it's what appears on the periodic table. However, an easy way to check that your answer makes sense is to look at the masses of the isotopes and check that your answer is somewhere in between the two. If your answer isn't somewhere between the two, you've either typed the numbers in correctly into your calculator or you're not using BIDMAS correctly, in which case you need to double check that you're using your brackets and other things on the calculator in the right order. Let's look at another example. In this example, they are telling us that potassium has got 3 isotopes, which means when we do the relative atomic mass formula, we're going to do 3 bits. We're going to do the percentage times the mass of one isotope added to the percentage times the mass of the second added to the percentage times the mass of the third, again all divided by 100. So in this case, we've got potassium 39 at 93.25%. 93.25 times by 39 added to potassium 40 with abundance of 0.02, and finally potassium 41 with an abundance of 6.73. All divided by 100. The best way to make sure that you don't make any mistakes is to show all of your working and to double check it. So therefore, doing the first calculation, 93.25 times 39 comes to 3636.75, added to this times this, which is 0.80, added to this times this, which is 275.93, all still divided by 100. The top line, when you add them all together, comes to 3913.48. Divide that by 100, and our answer comes to 39.13. Now at this point, you need to step back and have a think. Number one, does the answer make sense? It's in between 39 and 41. Therefore, it's a plausible answer. The isotope with the biggest abundance is 39. Our answer is quite close to 39, so again, that makes sense. Finally, we need to think about how many decimal places we're going to quote the answer to. Now, if you look at the question, all of the percentages that we are given are to 2 decimal places. Therefore, you round to 2 decimal places, which is why when I divided by 100, I haven't included the 48 on the end of here. The only thing that you need to watch for when you're doing these calculations, apart from your maths, is the wording of the question. So there are 2 main ways that they can tell you what the mass of the isotopes are. So for instance, we have been using a version where we write 39 at the top, followed by the K, which is what you would see on a periodic table. It is, however, just as common to see the name of the element written in words with a hyphen followed by the mass. So you need to make sure that you're prepared to do either of those questions.